Welcome back to our tutorial question. We continue from last week. Okay, we have a question 9 here that we did not, okay, Evan, your teacher didn't tell you to take average, you must take average. You repeat it 3 times, right? You must take average. Okay, so this is one of the PSLE feedback. Students don't say that they take average. So I have more things to cover with you as we move on from P5 to P6 also. So that means our year end, okay, head start. We are covering next year's topic. I'm also going to go through things like claim, evidence, reasoning. We have to go through all these things, practice and practice and practice. Okay, because this is the year end. When the school start already, we have to cover a lot of the content. So this year end, make sure you sign up. We are going to cover next year's topic as well as special skills for you to learn. Okay, so you practice more, you become very good. And certain type of question like the water question, how do you answer? Then I can expose you to many water topic related question. Okay, and how you can apply similar answering technique to the questions. You think you like that? Okay, that will prepare you better for your PSLE. Jokai, you didn't learn that also, the average. Yeah, I need to take average. Okay, take a look here. Now, they start off with, or May started off with 2 identical containers, X and Y. Each has the capacity 500 cubic centimeters. She placed them on a balance as shown in the diagram. So in this diagram, you have container X, container Y. Each of the container has the same volume of air. So when you put it on the balance, can you see that it is really straight and horizontal? Yeah, it is not like slanted here and there. Yeah, this is easy, correct? The concept is actually on air, right? And the topic that they are testing you on is actually on matter. Yeah, so some of you already know this. Okay, May pump in another 100 cm³ of air in container Y. That means container Y, you add in 100 cm³ of air. So total, this is how much? Total is 600, right? So you have more air inside container Y now, right? Not the container stays the same size, but there's actually more air particles inside. And you must recall, all right? Air has mass. Remember the definition for matter? Matter is anything that has mass and takes up space or occupies space. So these are the 2 things you must know. Okay, so right now, what do you think will happen? Container Y will be heavier, correct? So this is going to be the observation she makes. I remember Jokai said last week, you're not so sure about this question, right, Jokai? Yeah, I remember up to today, I still remember. I told myself I must explain this, okay, because I noted down notes for my classes also. Whenever y'all say don't understand certain thing, yeah, I will cover it when the time is right. Okay, so this is the answer. Right, so the scale will look like this now. The balance is not horizontal. It is actually slanted to one side where there is more air. So what does this tell you? What is the property of air shown here? Okay, Evan, you already typed in for me just now. Air has mass. Thank you very much. So that's the thing, because we added extra amount of air and air has mass. It will cause container Y to be heavier. Okay. Okay, now over here, May has 2 strings, A and B. So A is filled with water, B is filled with air. When you see questions like this, maybe it will be good for you if you were to highlight the necessary information. So you see, she was able to push the plunger inwards for string B. Okay, over here. All right, so this is air and this is water. So able to push. But the other one, she was unable to push, right? The plunger. So what does it mean to you? Okay, what is the difference here? State one difference only here. in the property between water and air in a syringe. So this is the information that you have gotten. Okay, you know that one, you can push the plunger in, the other one you cannot. So already it shows you something that you already learned. All right, so you can see that air can be compressed, right? And then since over this side, you're unable to push the plunger, you say that water cannot be compressed. Do you all see this? Have you all observed this already? And do you recall all these important words? The water cannot compress, but the air can. Emma, yeah, concept-wise, you are correct, but the way you are writing it down, be very careful. Okay, so this is the suggested answer. Liquid water has a definite volume because whether a substance can be compressed or not is also telling us something about the volume, right now. Okay, when something has definite volume, it cannot be compressed. When its volume is not definite, for example, the gas, I put this amount of gas in a big room, it will occupy the whole space. I put this same amount of gas into a small box, it will occupy the space in the box. Clear? Okay, so this is how it works. So in this case, I have written this one, right? Some students would have written the one on volume. Nothing wrong. Same concept because they are very much related. Can we say water has a definite volume, but air does not have a definite volume? Yes, you can say that. But to be safer, if you write down liquid water, okay, it sounds better. But then, again, because the question did not say liquid water, right? So, Hanin, the way you're writing it, yep, I will give you the marks. Because you are just referring or you are lifting the information from the question, right, Hanin? Okay, so let's go on now. Worksheet 38. This is a block of melting ice. Okay, it's placed in a beaker as shown here. So what will happen to the temperature of the air inside the beaker and the temperature of the melting ice during the process of melting? Now, in the process of melting, we know that the temperature must stay the same. Do you recall? Okay, if you don't remember, this is the time you remember now. We have learned this already. Okay, when do you learn it? When do you learn it? Anyone can recall? Just now? Just now. So cute, like all of you. Have you all learned? Last year, yes. Okay, where, under what topic? Under P4 matter, yeah, okay. Some of you probably learn it together with the topic on heat. Yes or no? Yeah, heat and matter, they are so close together, right? Because changes of state actually is very much related to heat. Whether heat is gained or heat is lost, it will determine the states of the matter. Oh, okay. Gordon, you learned it this year. Gordon, your school actually moved the topics, is it? Because heat is supposed to be taught in lower block. Heat as well as matter as well as light. They are classified under the lower block. But you only learned it this year, but that's fine. Okay. Can. So answer is C, temperature will decrease, right? Why will temperature decrease? Someone tell me quickly inside the chat. Write down. Let me see your knowledge of melting, knowledge of heat transfer. Light and matter last year, Gordon. Okay. Now, I'm just writing this down. We know that heat actually moves from a warmer region or a warmer place to a cooler region. Region is like area, is like a place. okay, or it can be, for example, that region can be the cup, etc. So heat always moves from a warmer place to a cooler place, right? So yes, I saw you have typed it in, okay? The air will lose heat to the ice cube. Ice cube is cooler, right or not? Okay, surrounding air is warmer. So warmer air loses heat to the ice cube. That's right. That's why after it has lost heat, right, its temperature will decrease. Okay. Ice cube gain heat and melt. The air in the beaker actually lost heat to the ice. Yep, it's true. The heat gained by the ice cube is used for the process of melting, so the temperature remains the same until the process of melting finishes. I like this. Can I just copy this and share with everyone, Hanin? Okay, this is what Hanin actually typed in. I want y'all to take note. Yeah, this is the reason. Right, you are going to learn in secondary school why the temperature stays the same. Okay, there is a particular explanation to that. You will learn it in, let's see, I think in Sec 2. Okay, beginning of Sec 2, around maybe February or March, you will start learning this topic. Okay, how come temperatures stay the same? You need to go to even the particle level. Remember, Miss Day drew for you how particles look like in liquid, in gas, and in solid. Yep, the last lesson. So when you want the ice to melt from solid to liquid, okay, the energy is actually, the heat energy is taken in by the particles such that they can start moving all over, okay, around each other. Okay, so that is why it's happening, but I don't want to go into the scientific description, the explanation. It might confuse you. All right, but when you go to Sec 2, you're going to learn this. Okay. Evan, you asked me that question, right? Why stay the same? You don't have to know now. Just know a very simple one given by Hanin. Right? I think Hanin, you learned this from your teacher also, isn't it? Then your teacher would have told you a very detailed kind of explanation will be required only in secondary school, I'm sure. Yeah, it's the same. When I was teaching this in primary school, students asked the same question. Question 2 here, Alice wanted to find out how exposed surface area of a handkerchief affects the time taken for it to dry. So she hung 3 of the identical handkerchief, A, B, and C, containing the same amount of water out in the sun. Each handkerchief was folded to expose a different amount of surface area. So the 3 handkerchiefs were weighed, okay? They were weighed after half an hour. Her results are shown in the graph below. So what she actually did was, okay, there was a duration of half an hour. She took some measurements, right? And the measurements were actually the mass. Okay, so she took the mass of the handkerchief. All right, then the time that she waited was half an hour. That means this has got to be time, right? Okay, at time 0, that is the beginning. All of the handkerchief will have the same mass because they have the same amount of water. Can you see that? So right from the start, they all have the same mass. Okay, so they started at the same point. Okay, so this must be the mass of the handkerchief with the water. Okay, so half an hour later, so this must be the half hour later. Supposing this is in minutes, then this will be 30 minutes, right? Okay, so if this is in hour, then we put it as 0.5. So 30 minutes later, this is what she actually obtained for the mass of handkerchief A, handkerchief B, handkerchief C. So of course, our answer here is B. Should have no problem, right? I look at the number of you getting it wrong. Actually, it's pretty low. Okay, good. Now, so can I ask you one thing? Can I ask you one thing? Out of A, B, and C, right? These 3 handkerchiefs. Yes, Rachel, go. Out of these 3 handkerchiefs, Okay, which one has